My name is Flores and this is my channel.
Hi, my name is Flores, speaking once again. Good day. For today's video, let us discuss about the basic derivative rules or basic rules of the derivatives. So, at the end of this video, the objectives is to help learners apply those basic derivative rules in differentiation, while differentiation defined as the process on solving or finding the derivative of a function or a equation. But first, let us derive what is derivative. Derivative defined as the slope of a curve at a point on the curve, defined as the slope of the tangent to the curve at the same point. The process of finding the derivative is called differentiation, and this process called differentiation is central to the branch of mathematics called differential calculus. So without further ado, let's tackle the main topic of this video, which is the basic derivative rules, and it includes the constant rule, constant multiple rule, power rule, sum and difference rule, product rule, quotient rule, chain rule, where each of these rules have its characteristics that makes one different from one another. For example, here in constant rule, where f of x is equal to c, then f prime of x is equal to 0. Noted that f prime of any function is considered as the first derivative of the given. So, second one would be constant rule or constant multiple rule. Again, constant multiple rule, where g of x is equal to c multiplied by f of x, then g prime of x is equal to c multiplied by f prime of x. Next would be the power rule, and if f of x is equal to x raised to n, then f prime of x is equal to n x raised to n minus 1. Next would be the sum and difference rule, where h of x is equal to f of x plus minus g of x, then h prime of x, or the derivative of our x, h is equal to f prime of x positive negative g prime of x. Next would be the product rule, where h of x is equal to f of x, g of x, then h prime of x is equal to f prime of x multiplied by g prime of x plus f of x multiplied by g prime of x. Or, let me read it again. The derivative of the function of h of x is equal to the derivative of x, f of x, multiplied to the given g of x plus f of x multiplied to the derivative of g of x. Next would be the quotient rule. H of x is equal to f of x all over g of x. Then the derivative of h of x is equals to f prime of x, or the derivative of fx multiplied by g of x minus f of x multiplied to the derivative of g of x all over gx squared. Next would be the chain rule. Chain rule, where h of x is equal to f quantity of g of x. Then h prime, or the derivative of h of x, is equal to f prime quantity of g of x multiplied to the derivative of g of x, or g prime of x. So in order for us to apply these derivative rules, let us give some examples in each of the derivative rules. But let me clarify, I do not include the constant multiple rule, for it is understandable if you are already mastered the constant rule itself. So first is we have this constant rule, where f of x is equal to c, then f prime of x is equal to 0. So this would be the given here, where y is equal to 780. If we were going to find the derivative of this given, and then we apply the constant rule, the derivative would be equal to 0, since c is equal to 780, where any constant in constant rule in finding the derivative would be equal to 0. Next would be the power rule, where f of x is equal to x raised to n, then the derivative of f of x is equal to nx raised to n minus 1. So given with this example here, where y is equal to 4x cubed plus 2x squared. So if we were going to find the derivative, it would look like this. The result would be f prime, or the derivative of y, is equal to 12x squared plus 4x. And this would be the process applying this power rule. So we have this y prime is equal to 3 multiplied by 4, since 3 serves as the power, and then as you observe here in the power rule, we need to multiply the number or the number of the power itself to our coefficient, where in this given we have this 4 and the power would be 3, so we came up with 12. And it is also said here in the power rule that we must minus or subtract 1 from our coefficient, so we came up with x squared as the remaining coefficient. Plus 4x, is it because we apply the same process. We multiply the coefficient to the power, which is the squared or the 2, so we came up with 4, and then x as we subtract minus to 2. So from the given y is equal to 4x cubed plus 2x squared, the derivative would be y prime is equal to 12x squared plus 4, applying the power rule. It is also noted that there are many cases that in one equation, some of the rules are required to apply for us to apply also the other rules. For example, here in the sum and difference rule, where h of x is equal to f of x plus minus g of x, then the derivative of h of x, or the h prime of x, is equal to f prime of x plus minus g prime of x. So given with this example here, we have y is equal to x raised to the power 4 plus 15x squared minus 3x cubed plus 9. As we apply the sum and difference rule, we came up with this process. As you observe, we also apply the power rule and the constant rule. Here, y prime is equal to 4 multiplied by 1 times 3. Observe that it is the power rule, plus 2 multiplied by 15x, power rule again. The minus here would be the sum and difference rule, and 3 times 3 x squared is applied by power rule also, and then plus 0, since 6 is just a constant, and any constant must be equal to 0 considering the constant rule. So we came up with this derivative from this given y is equal to x raised to 4 plus 15x squared minus 3x cubed plus 6 up to y prime of the first derivative of the equation is equal to 4x cubed minus 9x squared plus 30x. So next would be the product rule, where h of x is equals to f of x g of x, then the derivative of h of x is equal to f prime of x multiplied to g of x plus f of x multiplied to the derivative of g of x. So given with this example here, noted that in considering the product rule given here, the first quantity serves as our f of x, and the second quantity serves as our g of x. So as we solve this given, which is quantity of x squared minus 5 and quantity of x cubed minus 2x plus 3, as we solve this and find the derivative of this given, we came up with f prime of x 2x, since it is the derivative of our f of x, which is x squared minus 5. We apply power rule and constant rule, so we came up with 2x as the derivative of our f of x. Next is just copy the g of x, which is x cubed minus 2x plus 3, and then plus, since we are in product rule, and if we are in quotient rule, we need to use subtract or minus. Next would be we need to copy the f of x, which is x squared minus 5, and then find the derivative of g of x, which is from x cubed minus 2x plus 3, we came up with 3x squared minus 2. And then just multiply and combine like terms, so we came up with this, which is 2x raised to the power of 4 minus 4x squared plus 6x plus 3x4 minus negative 17 or plus 17x squared plus 10. So we came up with f of x is equal to f x 5x raised to 4 minus 21x squared plus 6x plus 10. Next would be the quotient rule. Here in quotient rule, where h of x is equals to f of x all over g of x, then the derivative of h of x would be f of x multiplied to g of x minus f of x multiplied to g prime of x all over g squared, g of x squared. So given with this example here, we have f of x is equal to x squared plus 1 all over 5x minus 3. So assume that x squared plus 1 is our f of x, and then 5x minus 3 is our g of x. Just repeat the process. We need to find the derivative of our f, which is x squared minus 1. So we came up with 2x, and then copy the g of x, which is 5x minus 3. Minus, as what I have mentioned earlier, that in quotient rule we need to use the minus operation. So we need to copy x squared plus 1 since as our f of x, then find the derivative of our g of x, which is 5x minus 3. So it is observed that it would be equal to 5, and then just squared our g of x, which is 5x minus 3, as our denominator. So f prime of x is equal to 5x squared minus x squared minus 5 all over 5x minus 3 raised to, or minus 3 squared. Here in our numerator, we just simply distribute each terms to the inside the quantity. So we came out with 10x minus 6x, 10x squared minus 10 again, 10x squared minus 6x minus 5x squared plus 1. So we came up with this 5x squared minus 6x minus 5 as we organize the formation according to the power or the standard, which is ax squared plus bx plus c. So we came up with this derivative of the function given here. Next would be the chain rule, where h of x is equal to f quantity of g of x, then the derivative of h of x is equals to the derivative of f quantity of g of x, and then multiplied to the derivative of g of x. Just like for example here, we have this given f of x is equal to x cubed plus 4 raised to the power of 4. So as we apply the given here as our guide, which is the derivative, we're finding the derivative of h of x. So f raised the power f outside serves as our power, since we need to multiply this power to our coefficient, so it serves as our f, and the f of prime f or f prime multiplied to the derivative of x cubed plus 4. So we came up with 3x squared, and then just copy the g of x, which is x cubed plus 4 and raised to 3 as we subtract 1 from 4, and then distribute the given, and then we came up with 12x squared quantity of 3 cubed plus 4 raised to the power of 3. We can simply solve this problem, but in this situation we are asked to find the first derivative only of the given. So that will be all.